Good afternoon, my dear students. Welcome to one more amazing session from Infinity Learn from Sri Chaitanya. Good afternoon. How are you all? Please confirm. Can you able to hear me and see me? Good afternoon, Anamani. How are you? Today we are presenting Chemical Kinetics on YouTube platform by Sri Chaitanya by Infinity Learn. And welcome to NEET STEP UP 2025 program. In this program, we are offering physics, biology and chemistry sessions right from 12 o'clock to evening 6 o'clock. And you all use these sessions and get benefit of it by simply attending the lectures every day without fail. Good afternoon here. And you also like these sessions and share with your friends and subscribe to NEET STEP UP 2025 program. In this NEET STEP UP program, we are offering these sessions. I am Suresh, faculty of chemistry, and discussing about all the chemistry topics related to NEET, right from Monday, Tuesday, Wednesday, 11th topics. In this particular week, we had a discussion about thermodynamics, an outstanding discussion, and Thursday, Friday and Saturday we are in the journey of chemical kinetics. फिलहाल हम खत्म कर लिया जीरो ऑर्डर एंड फर्स्ट ऑर्डर एंड रेट ऑफ ए रिएक्शन हिसाब से, एंड आज से आप शुरू करने वाले हैं मॉलिक्युलरिटी एंड ऑर्डर एंड देयर एप्लीकेशंस एंड Arrhenius equations, and that is the agenda for today. And for the formalities we need to do, we are Infinity Learn what we do and what we are going to do for you. Are you ready to take that? Ishita, good afternoon. It's a light 5 minutes promotional slides आपको देखने वाले हैं, and you can see my dear students in this. Students are shown right now, and Ashrita and Akhil Verma and Hemadyuti and Satyanarayanan. These students secured very less marks, around 300 and odd in 2023 NEET examination. आपका जैसे करते, and they upgraded themselves by enrolling in certain programs offered by Infinity Learn, and you can see Ashrita got a 351 marks increment, and Akhil Verma got 345, and Hemadyuti got 342 marks increment, and Satyanarayan got 320 marks increment in this journey, and only 4 students are shown here. And you also see hundreds of students achieved their score improvement around 300 like you will be doing in 2025, and you will be the next for 2025 examination. Are you ready? And what we do and what we offer. Yes, we are going to give you NEET 2025 rank assurance program. Yes, in this rank assurance program, you can see all these features like 480 hours of live classes with complete NEET syllabus, and downloadable notes are available, and class recordings are available, and जो भी class है, ये class का recording आपको मिलेगा, and DPP भी आपके सामने है ना? And you can do practice with the DPP, so that concept class में है, DPP practice में होना है, and 5000 plus topic wise recorded videos कहीं भी कभी भी आपको brain में spark करते हैं, आप recall करते हैं, a pool of 5000 lectures you can get it, and weekend test series with rank analysis and the paper discussion as well, and it is done by full syllabus mock test with detailed reports. अगर आपको detailed report मिलेगा ना, you can understand आप कहाँ करते हैं, क्या करना है आगे बढ़ने के लिए, है ना बेटा? Yes, and you will be having 24/7 doubt removal resolution by add for any question on doubt removal app. Ishita, are you ready to take this? And 30 NEET Achiever series printed books will be coming to your doorstep, my dear students. Parent teacher meeting is also there, and the progress of the discussion we will be having with you and parents and Infinity Learn eminent faculties that are there in front of you, right? And you can see the statistics in 2024 examination. There are 9 students who got 720 out of 720, and there are 45 students below 100, and there are 132 students scored, and there are 700 plus students are there. And why late? And this is the NEET Restart Your Program, and you will be having various silent features, and you have a special discount if you use Suresh 50 is a course coupon, and if you use this course coupon Suresh 50, ये प्राइस से आपको कम से कम 20% डिस्काउंट मिलेगा। आपका कूपन कोड कैसे इस्तेमाल कर सकता हूं मैं आपको इसी वक्त में बता दूंगा, है ना, राइट। नाउ लेट्स टॉक अबाउट हाउ टू एनरोल इन ए कोर्स। इट इज वेरी सिंपल, it is very simple, and I want to show you how to do that. And in this you can see this is my live session that you are all observing, and in that description box you can see here first link infinitylearn.com NEET repeaters program, and in this NEET repeaters program you can see the main page that you can see, and what is the courses and everything I explain you guys, and these are the key features and comprehensive video lectures. 6800 plus NCERT aligned video lectures are available, personalized learning experience available. You all just have one click so that you can see the same screen there, right? And targeted practice questions and national level mock test, performance benchmarking, and detailed study materials, and also efficient revision tools. You have AI supported tools, and expert doubt resolution, and unlimited practice test. Course for the higher score, and you will be having various courses that are available there, and you can see how to enroll. You just see here, you just see various courses. Yes, in that you can enroll any course of your interest. So enroll now, upcoming schedules are available, and you can go for enroll now. When you go for enroll now, the course is available here. In that course you can see directly, and just one click away you can click on buy now. In that you will be having a coupon code will be allowed here. Verify your phone number. Once you verify your phone number, and you will be getting an OTP for that. Once let me give you, yes, once you open your page and the payment gateway will be there. When you go for the payment gateway, you will be given a coupon code. What is our coupon code? Yes, what is our coupon code? Here it is clearly mentioned. I just want to show you. Suresh 50 is the coupon code. You can directly use that, and you are going to get 20% off on any course that you are going to enroll it. Is that fine? So I want to see you directly on the course enroll, and I am personally come and may visit your page, and I can be your master teacher there, and many eminent faculties are there, not only me, and you are going to get an awesome result, believe me, in 2025 NEET examination. So what late, we are going to see the courses, and we are going to rise up with an excellent result from NEET 2025. And don't forget, this is a NEET course. It is Suresh 50 is the coupon code, right? And we are going to enroll that. Don't forget this code, Suresh 50. Okay, so without delay we go into the chemical kinetics. In this, what you learn in the chemical kinetics, rate of a reaction. So promotion is completed. Let us talk about the academics now, my dear students, and factors affecting a rate of reaction, and integrated rate loss, and analysis of first order reactions, molecularity of the elementary reactions, and effect of temperature on the rate, and also we are going to see Arrhenius equation and activation energy and their applications. So yesterday in the class we completed zero order and the first order. Remember the rate of a reaction, and average rate of reaction, and differential rate of reaction, and we have zero order integrated rate expressions and first order rate of integrations and half life and everything we learned. And let us talk about the features of the first order reaction. What exactly the first order reaction says? K is equal to 2.303 upon T log to the base 10 of A naught by AT. है ना? So what is A naught or C naught by CT? Let it be anything. A naught or C naught is initial concentration, AT or CT is the concentration at time T. In that we are going to see various features of the first order. First order reaction must follow the above form of rate law and at all time instances. This means that if you are given a value of A naught or C naught and the x at differential time of, that is C naught minus x, as a value of reactants after time t, the value of K can be calculated from the differential equation only. Yes. So Ishita, fine? Ishita, right. Now let us see the time for the half reaction for the first order reaction is independent of initial concentration. Why? Because T half for the first order reaction is equal to 0.693 by K. This is very, very important. So that if you talk about T half and with respect to the concentration of A, it is going to be independent, right? It is very simple. It is very simple. And also say the concentration of the reactants in the first order reaction decrease exponentially with time. You can see the graph. You can see the graph. And let us say, yes, concentration versus time. You can say log concentration versus time. You are going to get a straight line and with a negative slope. That negative slope is going to give you minus K by 2.303. So I just want to say, if slope is given, you can calculate the rate constant. This is an important one. This is an important one. So from the slope you can calculate rate constant for the first order reaction. You're all there, right? Okay, fine. Now let us see some more things about this. And the rate constant of first order reaction can be calculated by measuring the concentration of a reactant at two intervals. So in the previous one, what we had, so if initial concentration is given, concentration at a time t is given, you can use this particular expression. Or else you can also say this one, hi, you are Gul. Nice name. You can say rate constant can be calculated from 2.303 upon T log C naught upon Ct. So what is the C naught here? Initial concentration. यहाँ पर C naught है initial concentration at concentration time T. Everybody knows this. But when it comes to the examination for NEET kind of competitive examination, sometimes initial concentration will not be given and you will be given concentration at two intervals of time. Right? In that two intervals of time, if the initial concentration is not known, what to do? Simply, if C1 and C2 are the reactant concentration at respective time T1 and T2, then the relation between C1 and C2 and T1 and T2 can be given as 2.303 log to the base 10 of C1 upon C2 is equal to rate constant K of T2 minus T1. एक खतरनाक फॉर्मूला है, ये खतरनाक फॉर्मूला इस्तेमाल करके आप नीट एग्जामिनेशन में सीधा कर सकते, क्योंकि जो स्टूडेंट आते हैं ना, so when this kind of questions are coming, you will be identifying where is initial concentration. इसमें initial concentration दिया नहीं, लेकिन आप निकाल सकते हैं rate constant के value का, है ना? Yes, very good. Let's see some more things about it, right? Now let's talk about, so the rate constants and the amount of the substance at different concentrations. T half for the first order reaction is going to be 0.693 by K, मान लो ये वाला जो है, and after first half life concentration at time t is equal to C naught by T, है ना? And second half life it is going to be C naught by 2 square, and it is for Ct by C naught is equal to 1 by 2. So you can say Ct by C naught is equal to 1 by 2 power square, right? Now you can say for nth half-life you are going to get Ct upon C naught is equal to 1 by 2 to the power n, where n talks here number of half-lives. That's very important. लॉजिक क्वेश्चंस ब्रेक करने का ये फॉर्मूला बहुत ही इंपॉर्टेंट है. Got it, Ishita? So let's see carefully these formulas. Whenever I am giving the formulas, you follow the formulas as such and you can do the best. है ना? That's good. Now let's talk about, note the differential rate can be integrated from nth order reaction can be given as 0 order or first order for E half is equal to 1 by initial concentration to the power n minus 1. Fine. Are you able to hear me? And you just give a confirmation, dear children, because there is a lag in the net connection. So that you please confirm. Can you all able to hear me? Can you all able to see me? Fine. Fine. Ek thumbs up and fire emoji. Fada first. Yes, that's good. Thank you. So let's do some more. So order of a reaction n can be calculated from the T half. So how? Yes, how T half is related to the order of reaction n. That is given as T half for the first reaction upon T half for the second reaction is equal to initial concentration for the second reaction upon initial concentration of the first reaction and to the power n minus 1, where n can be evaluated, that is order. How do I evaluate from the n value? By taking the logarithm values. Taking the logarithm, we are going to get order of a reaction is equal to 1 plus log to the base 10 of first T half upon second T half upon logarithm to the base 10 of first initial concentration upon second initial concentration. This is very, very important. If you want to go to All India Institute of Medical Sciences, you need to do cracky questions at the end. So this is the one which is very, very, very important. And you all make a note of it. You all make a note of it. Yes, you can do. Yes. Now pseudo first order reaction. ये pseudo first order reaction है क्या? So pseudo first order reaction is a reaction which is actually a bimolecular reaction. Confirm, dear students? Any lag? So any gap? Some lagging is there. If everything is fine? Is everything is fine? Confirm? Okay. So let's go ahead, and this is actually order 2, gap is there. Okay, order is 2, but it becomes order 1 if water is taken in large excess. Its constant active mass change constant is going to be 1 and it is behaving like a first order reaction. So this is actually not a first order but behave like a first order. This is what you call it as pseudo first order reaction. And one more example, cane sugar on hydrolysis gives glucose and fructose. So this hydrolysis of fructose is going to be again a pseudo first order reaction. Generally hydrolysis reactions appears like a first order reaction. Are you getting or not? So come on, so let's see some more molecularity. What is molecularity? So far what we have done, we just recap what exactly happened in the previous class. Now from now onwards we are going to see so much concept as far as the NEET examination part is concerned. So let's see, okay, who is there on the other side? Ishita, Abhinav is there? Okay, and many students are not actively charting in the class. Okay, I request you come and interact with me. It's not like a radio telecast. So here you can talk to me and I can talk to you on this YouTube platform. So I really appreciate those students who are regularly coming and attending the classes. Okay, that's good. Let's see. So molecularity. During a chemical reaction, the reactant molecules make a collision. So how many molecules are making a collision in a single step? That number of molecules is called as a molecularity. So the order of a reaction is actually experimental concept. The theoretical aspect of the chemical kinetics is actually the molecularity. And the complex chemical reaction is understood in terms of various indirect steps called elementary processes or elementary steps. So if the reaction is so complex, you have to take steps. So each step is called as a elementary reaction. So elementary reaction will have theoretical molecularity, and the study of the reaction in terms of elementary process is called the reaction mechanism. So a molecularity reaction mechanism में इस्तेमाल कर सकते, and now various elementary steps can occur at different rates, and the slowest elementary process in the reaction mechanism is called rate determining step. You can say RDS. कहीं सुना ही क्या? जो ऑर्गेनिक में आता है रिवर्सिबल एंड इंटरमीडिएट फॉर्म होने का स्टेप है, दैट इज कॉल्ड रेट डिटरमाइनिंग स्टेप. ये रेट डिटरमाइनिंग स्टेप का आपका कितना मॉलिक्यूल्स making a collision, that is what you call it as a molecularity. Molecularity is defined as the number of ions or molecules or atoms or in reacting species taking part in elementary step is called the molecularity. This molecularity is the backbone for the mechanisms that you study in the organic chemistry, my dear students. Okay, so let's talk here more about various types of molecularities. If the molecularity is one, that is called unimolecular. And cyclopropane is converted into propene. So this is a unimolecular reaction. O3 decomposes to gives rise O2 and a nascent oxygen. It is a unimolecular reaction. N2O5, N2O4 plus of O2. This is a unimolecular reaction. Dear students, you can say bimolecular reaction. इसमें bimolecular means molecularity इसका दो होगा. Molecularity उसमें दो होगा. So Ishita, right? So when you talk to me na, I am going to experience what you understand. Then we are going to discuss according to your requirement, right? So NO plus O3 gives rise NO2 and O2. उसमें दो molecules A step में making a collision है ना, and HI two molecules है. So that molecularity इसका दो होगा. You can also see termolecular. Termolecular उसमें molecularity तीन होगा. So there are three molecules which are making a collision, and उसमें एक है, उसमें दो है ना? Yes, it is. Okay, so molecularity is going to be 3. So molecularity can be 1, molecularity can be 2, molecularity can be 3. Molecularity can never be 0. Molecularity can never be fractional. Molecularity can never be greater than 3. If the molecularity is damaral, so if molecularity greater than 3 होगा तो क्या होगा? Molecularity 3 से ज़्यादा होगा तो क्या होगा? 3 molecules, more than 3 molecules at an instant can't make a collision, so that we have to split that reaction as a complex reaction to be into simpler forms. So you have to see the collection of elementary steps. है ना? Right. Damarlal. Now let's talk about For a reaction, A gives rise to B in the rate law is going to be K, A to the power M and B to the power N, where M is the order with respect to A, N is the order with respect to B, and A, B and their powers M plus N is going to be the overall order of the reaction. So neither the order of reaction M plus N nor the molecularity of the reaction can be predicted from the stoichiometric coefficients of the balanced chemical reaction. ये बहुत important चीज़ है बेटा, क्योंकि you can see this is the point. Actually the students miss Ishita and go for the wrong answers. Why? Because by looking at the stoichiometrically balanced equation, you want to write some order, ये गलत बात है. Order is experimentally determined values. So we can say the order of a reaction is always determined experimentally, while the molecularity is determined theoretically. Order is experimental and molecularity is theoretical, है ना? And you have to study the reaction in various way. However, as theoretical ideas, sometimes we can have an approximate order of a reaction equal to the molecularity, can give approximate values, approximate assessment, but not exact values, and that is the number of molecules taking part in the slowest elementary step for a complex reactions are required. So order of reaction can fraction also, can be fractional, can be 0, yes, can be fractional also. मान लो एक example H2 plus Br2 gives rise HBr. The rate of a reaction K H2 and Br2 power 1 by 2. If you say इसका molecularity 2 होगा, लेकिन molecularity as 2 molecules are participating, it is going to be 2. लेकिन इसका ऑर्डर कितना होगा इशिता बोलो, इसका ऑर्डर कितना होगा रेट लॉ का हिसाब से? नवीन कुमार, हेलो एवरीवन. सो इसका ऑर्डर कितना होगा नवीन कुमार, यू टेल मी. नवीन, दमर, इशिता, अनमनी, इसका नंबर 1 है ना, इसका नंबर 1/2 है ना, 1.5. अंडरस्टैंड? सॉरी, it is 1.5, 1.5. The sum of the powers is called as an order, right? That's a clear indication. And the order of a reaction can be 1 and 2, 3/2, okay, 1.5. Now, if you take one more example, I have acetaldehyde is giving rise to methane and carbon monoxide, and इसका molecularity हमको देख रहे 1, yes, and इसका experimentally determined, it is experimentally determined, it is going to be 3/2. So also note the sum of the stoichiometric coefficient 1 plus 1 is equal to is not equal to the order of a reaction. And let us see various things here, and very important, it is only useful for NEET tug of war questions. Sometimes in the NEET examination, the like unit you will be having a difficult level questions. To crack these difficult level questions, you need to study these methods of determining the order of a reaction. Get ready, we are going to give you use of differential rate expressions. You can use integrated rate laws, you can use half-life method, and you can use isolation method. है ना? So let us talk about this. Let us talk about these methods one after one. Are you ready? Are you ready? Right. So let us talk about use of differential rate expressions. So when you have a differential rate expression, we know that for the nth order reaction, rate is going to be rate constant initial concentration to the power n, है ना? And taking the log on the both sides, we have log rate is equal to log rate constant plus n into log concentration. Here log concentration, by we can plot log r as a function of log c. It should be a straight line with a slope n, and that graph can give you, you can say, you are going to see log reactant, log concentration of A and also log rate and log rate, you can say log concentration of A and log rate, you are going to get a straight line with a slope, and as the slope is going to be n, you can calculate the order of a reaction can be evaluated. It is a simple method, but experimentally you have to connect these lines and have to draw a proper straight line. Are you getting or not? Are you getting or not? It's very simple. Yes. Now, use of integrated rate laws. Use of integrated rate laws. You have integrated rate expressions. From the integrated rate expressions, you have the k value. K value can be evaluated. The consistency of the k values obtained from these integrated rate laws. From that you can calculate. In the graphical method, if you plot log C versus T, a straight line, then the reaction is of first order, okay, and that is a plot of log C versus T, you are going to get a straight line and the slope is going to be minus k. Remember, when you learn the first order kinetics, this is the graph we learned, है ना? And similarly, the integrated expressions for the second order can be utilized to ascertain the reaction order is 2 and so on for the order 3, or like that it can be fractional also. And this integrated rate laws are related to graphs also. You have so many graphs in the NCERT textbook. There are 6 graphs that you can study, the 6 graphs like this, and you can do very good number of questions. So please have a good hold on NCERT textbook so that you can do the best in the NEET examination, my dear students. Ishita, fine? Naveen Kumar, are you coming every day, Naveen? Okay, Damarlal, when the class is going on, everybody, you just chill up and enjoy the class with a lot of enthusiasm, and you can really learn and enjoy. अरे पढ़ाई में मजा लूटने का कोशिश करो डियर. And also, let us go ahead. आगे बढ़ते हैं. आगे बढ़ना है. एक thumbs up and fire emoji डालो. इशिता, come on. Now, half-life method हम देख चुका. So, you just try to take the half-life at 2 different concentrations and you can evaluate the n value. So, n is the order, can be given as 1 plus log T half-life for the first experiment upon half-life for the second experiment upon log initial concentration of second experiment upon initial concentration of the first experiment, right? And this is a very important question, very important formula. You can do it. We have some important questions as well we can discuss. Dhirendra, myopia. Why myopia? You have any eyesight? You have any eyesight? So myopia, okay, and these are all comes in the biology beta, and we are discussing chemical kinetics in today's class. Let's go ahead this. No. It's not like that. So you have myopia, nyctalopia, night blindness, and short sight and long sight defects and all. So we will be discussing those things in the biology, not here, right? So let us learn chemistry, Dhirendra, here, and this is about identifying the order of a reaction from the T half-life of the reactants, okay, and isolation method एक काफ़ी important का है. Isolation method, this is important. Actually we follow the experiments, this one only. Actually we study the theory but we don't do the experiment. But this theory ये experiment के हिसाब से बना हो चुका, यही है. Isolation method is an experiment. Sometimes chemical kinetics are studied in successive experiments by keeping concentration of one of the reactant in excess so that result gives in the order with respect to the reactant whose concentration is changing significantly. So the synthesis of HI from H2 and I2, the pseudo first order reaction with respect to H2 in the presence of large excess of I2, and also pseudo first order reaction with respect to I2 in the presence of large excess of H2. Hence the overall reactions is going to be a second order, okay. And also logarithmic data method, you can take the logarithmic data method like this. You take the rate expression, and by the log rate is equal to log k plus n log a. Why we got that rate is equal to k a to the power n. You take the logarithm from either sides, log r is equal to log k plus n log a, so that log a dot b is equal to log a plus log b, and log a to the power a b is equal to b log a, है ना? Yes, from that. सर अगर कोई मेटल के पास 4 इलेक्ट्रॉन तो वो शेयर करेगा किस चीज़ के लिए? अगर 4 इलेक्ट्रॉन का मतलब ये कोवलेंट बॉन्ड का शेयर करता है ना? सो दैट डिपेंडिंग अपॉन द नंबर ऑफ इलेक्ट्रॉन्स इट कैन लूज और इट कैन गेन और इट कैन शेयर द इलेक्ट्रॉन्स, धीरेन्द्र, है ना? इलेक्ट्रॉन्स दे सकते कभी कभी, इलेक्ट्रॉन्स ले सकते कभी कभी, इलेक्ट्रॉन भी शेयर कर सकते. सो कोशल लुईस थ्योरी का वजह से Dhirendra is fine. Now let's talk about, we can take various data points, converting them to log values and plot them. We can obtain log rate upon log concentration. You are going to get a straight line. When you get this slope is going to be tan theta, gives you the order of a reaction. This particular thing intercept is going to be log k, and this data point verification graphically can give you the order of a reaction. नॉन मेटल गेन करेगा, कुछ एक्सेप्शनल है. नॉन मेटल हमेशा इलेक्ट्रॉन गेन कर सकते हैं, एंड मेटल्स इलेक्ट्रॉन डोनेट कर सकते हैं, एंड ए नॉन मेटल इलेक्ट्रॉन शेयर भी कर सकते हैं बेटा, कुछ एक्सेप्शन भी नहीं है. सो दिस इज द फंडामेंटल थिंग, है ना? धीरेन्द्र केमिकल काइनेटिक्स चल रहे, कम ऑन लेट अस डू. और एक चीज है, एनालिसिस ऑफ सम इंपॉर्टेंट फर्स्ट ऑर्डर रिएक्शंस. दिस इज वेरी इंपॉर्टेंट. एनसीईआरटी में एक दिया, थैंक यू वेरी मच. एनसीईआरटी में एक दिया, इसका वजह से डिकम्पोजिशन ऑफ हाइड्रोजन पेरोक्साइड इज देयर. सो certain first order chemical kinetics reactions we need to study. In that decomposition, H2O2 decomposes to gives rise H2 and O2. So the rate of the first reaction is measured by titrating fixed amount of H2O2 with KMnO4, so that the reaction between KMnO4 and H2O2 are seen, and here KMnO2 is oxidizing agent, H2O2 is reducing agent. It's a redox reaction, and the volume of KMnO4 is used is our data point, है ना? And the time instances t is equal to 0, and the volume of KMnO4 T1 volume is V1, T2 volume is V2, T3 volume is V3, like that. With this data ये डाटा पकड़ के हम क्या कर सकते हैं धीरेन्द्र? हाँ, यस, आप कर सकते हैं ये डाटा पॉइंट का. सो द रिएक्शन इज डायरेक्टली प्रोपोर्शनल टू द वॉल्यूम ऑफ द KMnO4 इस्तेमाल किया, है ना? So volume of KMnO4 at a time t is equal to correspond to volume of H2O2 initially present, that is C0 is directly proportional to V0. Tashwin is coming, Tashwin is coming. Okay, कल आए थे लेकिन गायब है, क्यों? Take these classes every student in a serious way, and you are putting an effort in the YouTube platform, you can do the best. Believe you can be the topper also. Believe it or not? Yes. Now you can see volume of KMnO4 at a time t, Ct is directly proportional to Vt, है ना? So that you can use this in terms of first order kinetics. So Kt is equal to 2.303 log V0 by Vt, and इससे हम रेट कांस्टेंट निकाल सकते हैं. calculation of the rate constant of the first order reaction experimentally from this data, so that you can be given in the NEET examination questions based on this. कैसे दे सकते हैं बेटा? So volume of KMnO4 अलग अलग टाइम में आपको दे सकते हैं. सो ये वॉल्यूम पकड़ के आप रेट कांस्टेंट के निकालना है. तश्विन समझ में आ रही क्या? वेरी गुड, नाइस. And let us talk about one more thing, and decomposition of ammonium nitrate, NaNO2 or benzene diazonium chloride. When ammonium nitrate decomposes, it's a first order kinetics. Sir, definitely in the equilibrium I am going to tell you. Maybe in the next week we will talk about the equilibrium. Tashwin, is that fine? Ionic equilibrium especially in that. Ready? Ready? Okay. Array, you don't keep quiet in the chart box. If you would have asked yesterday, today I would have get that slides now. Ready with that? Now let's talk. Ammonium nitrite on heating gives rise water and nitrogen gas. It's a first order. Or also benzene diazonium chloride gives rise chlorobenzene and nitrogen. Yes, by using Sandmeyer reaction you have organic chemistry also. So both the reactions, at a particular time volume of the nitrogen evolved can be studied. From this we can say at the time t clearly the volume of nitrogen is 0. So at the time instant t is at the end, infinite time means the end of the reaction, when the whole of ammonium nitrite or benzene diazonium chloride is completely decomposed. What happened? At the time infinity, volume of the nitrogen is going to be infinity, corresponds to C naught is directly proportional to V infinity. By using the first order kinetics, here it is the direct formula, Kt is equal to 2.303 log to the base 10 of V infinity upon V infinity minus Vt. Question solving chemistry. We have Tashwin, we have Infinity Learn Ranker series books. Those books are prepared by eminent faculties from the Infinity Learn. You can purchase it any course, so that 33 books you are going to get to your doorstep, so that you can do it. And 2024 NEET examination, total biology questions are from total from as it is from the in IL Ranker series books, and all the concepts from the chemistry and physics are from the Infinity Learn, IL Ranker series and Achiever series books. Right? No question is seeping away from Infinity Learn by Sri Chaitanya books. Tashwin, do you find? Is that fine? Yes. Let the viewers number increases, so that I can give you the promotional side once again, so that you can do the best. है ना? कर सकते हैं? Right. Now let's do here. Inversion of sugarcane is the other one. Inversion of sugarcane is the other one, and sugarcane on yes, done. Yes, hydrolyzed gives rise to glucose and fructose, where the sugarcane is actually dextrorotatory and the glucose is a dextrorotatory, and the fructose is the levorotatory. So but the optical magnitude of the fructose optical activity is more than the glucose, so that the total plus during this reaction become minus. This is called inversion. So the inversion of the sugar can be studied by using the polarimeter. Let us say this is the theta can be seen, and based on this theta and various times you can calculate. Here it is going to be this Kt is equal to 2.303 log to the base 10 initial optical rotation minus R infinity upon rotation at a time t minus R infinity. R stands for optical rotation. Is that fine? Yes. Very good. Now let's talk about when the first order reaction or gases are produced. Very important. Very important. I am discussing only at the level of NEET. है ना? You can see all the formulas that are available. In gaseous phase reactions, we prefer to measure the pressure of the gases or volume. For example, A is a solid and B is a solid and C is the gas. है ना? So when the first order reaction, gases are the one of the product. Tashwin, how to contact you, me and personally? Definitely you can contact me and personally you can connect. I am going to show you. Hold on, Tashwin, hold on. I am going to show you the promotional slides. There you can see how to connect with the Infinity Lane. There I will be available and you can talk to me directly. Right? Fine. Hold on. And so the data at 0, the pressure is 0 because there is no gas. At time t, the pressure is T, and the time infinite, the pressure is going to be infinite. So this pressure data point, the total pressure of the reaction mixture data point can give you a lot impact. That is from the K. So ln A upon A minus X is equal to KT. That is the fundamental first order chemical kinetics. So that when we put here at time t A 0 atm, because t is equal to time A minus X and t is infinity, A is completely consumed, it is going to be formed A and A. From there you can say Pt is directly proportional to amount of X, that is called consumed, and P infinity is directly proportional to A. P infinity minus Pt is equal to A minus X. Okay, A upon A minus X is equal to P infinity upon P infinity minus P time, right? So that by putting this, K is equal to 1 by T ln and P infinity minus P infinity minus Pt. So this you can do, or else you can also calculate that rate constant is equal to 2.303 by T log to the base 10 of P infinity upon P infinity minus Pt. Like that you can do many miracles with this. Yes, Tashwin, are you there? Tashwin, are you there? Okay, so my dear students, let us go back. How to go for my dream college is Delhi AIMS. What is the cutoff marks? So the cutoff marks is 700 plus for that. Those who secured 710, you are going to get in Delhi AIMS, right? 710. Ready? There are 9 students who secured 720 out of 720 from Infinity Lane. Do you believe that? Yes, you can have the slides. I can show you. There are 720 students. There are 720 out of 720, 9 students. 9 students are there. Can you believe it? And there are 45 students below 100. And ये फालतू नंबर का है ना ये बेटा, ये असली नंबर है, because this YouTube is a public platform and उसमें what we say गलती बोलने का कुछ फायदा नहीं है. And if there anything goes wrong now, we will be penalized. So there is no say these are all the false numbers. These are absolutely proved numbers. Yes, and there are 132 students who scored 700 plus. है ना? How to get into that beta? How to get into that? You take NEET 2025 rank assurance program with all these salient features. And you want to get into that, use Suresh 50 is the enrollment code. So जो भी कोर्स आप पकड़ना चाहता हूँ, so उसमें 20% आपको डिस्काउंट मिलेगा. So it is इतना सस्ता है, and no online education platform gives this competitive features, and in these salient features with this competitive and comparable match. So 705,000 and उसमें 20% कम कर दिया, बहुत सस्ता में मिलेगा. कैसे मिलेगा? And you can see I am going to show you. Yes, it is. So in this NEET examination, my session is going on, right? In this my session, you just simply look into the description box. There is a link is given, Infinity Learn Meta app ka. There is a link is given, Infinity Learn. Boost your NEET score with Infinity Learn. Yes, Tashwin, and boost your NEET course with Infinity Learn and enroll now, and you can directly click on that. You can have these many courses. You can have these many courses, and all the key features are available. All the key features are available, and in that you have whatever the courses you have, you can go with that. You can go with that, and you can enroll with that, right? And you can see. And you can click on anything on buy now. You can click on anything on buy now, and you will be having a verification your phone number. Once you verified your phone number, yes, send your OTP will be there. Once OTP is sent, you will be passing to your gateway. When you go into the gateway, you can add, what is the coupon code? What is the coupon code? You tell me. What is the coupon code you have? Suresh 50 है ना? ये Suresh 50 coupon code इस्तेमाल करो, है ना? This is your coupon code, and you can go with that, and इसमें आप बहुत सस्ता में आपका कोर्स मिलेगा, है ना बेटा? That's good. Suresh 50, fine. Now without delay, you all just use these salient features, so you can go ahead with that. You clicked it or not? Yes. So going ahead in the regular discussion of chemical kinetics, right? And कहाँ थे हम? यहाँ से कहाँ ढूंढ गया? Yes, Infinity Learn Meta app. You are going to have all the great things. You just join and you can see, right? And modified expressions for rate constant. Modified expressions rate N2O5 gives rise NO2 plus off O2. Why I made this? These are the regular equations that you are going to see in the questions. That's the reason why I made it. So iska K is equal to 2.303 upon T log V infinity upon V infinity minus Vt. Here Vt is the volume of O2 after time T. It's crazy. And V infinity is the volume of O2 after infinite time. It's crazy. How are you? Not coming nowadays. Okay. Now, और एक reaction है, ammonium nitrate on decomposition gives rise nitrogen gas, है ना? ये nitrogen gas seems the same expression with respect to this, right? So nowadays why you are not coming, Mr. Crazy? So one more student with your name. That's why I just saying the crazy name. Crazy chemistry. That student name is crazy chemistry. Okay. How are you? What's your actual name? So many students are asking, sir, how can I contact you? So I want to talk to you, give you a number, sir. If I give my number, it can be a public. So I will not be having in a personal life. So that you just enroll with your Infinity Learn packages, so that you can connect with me with the app. Okay, so that Shashank, nice name beta, nice name. God bless you. Preparing for NEET. Yes, Tashwin, is that fine? So let's see one more reaction. अगर H2O2 decompose करके H2O2 and oxygen बन गया, and the reaction rate kinetics is given as K is equal to 2.303 upon time log V0 and Vt. Yes, उसमें V0 है क्या? Initial concentration of KMnO4 and Vt, and the concentration quantity of volume of KMnO4 at a time t इस्तेमाल किया. So I am Dr. Suresh, Faculty of Chemistry from Infinity Learn. Okay, I am fine, thank you, Shashank. Okay, let's go ahead. And ester hydrolysis reaction, and I segregated all the reactions that you regularly see in नीट एग्जामिनेशन क्वेश्चन टेबल बना दिया। ये काइनेटिक्स में के निकालने के लिए यू आर गोइंग टू सी 2.303 अपॉन टी log v infinity minus v naught upon v infinity minus vt. Okay, and there sucrose, and sucrose is hydrolyzed so that you can get D-glucose and D-fructose, where you can see optical rotation inversion. Yeah, you study in Goa. Okay, I'll be coming to Goa very soon. Okay, during this monsoon or the end of the monsoon. Okay, now, and you can see the optical rotation K is equal to 2.303b upon time log optical rotation initially minus optical rotation at the end minus optical rotation at the time t minus optical rotation at the end, infinite time. And you can see a special question, I made it and I will discuss for you from a standard books. So this is your question. Azomethane CH3 twice N2 decomposes with the first order reaction like this. So it is going to, azomethane is going to give you C2H6 and ethane and nitrogen gas. And the following data were obtained during decomposition in 200 milliliter flask. At a time 0 minute, 15 minutes, 30 minutes, 38, 75 minutes. The total pressure is going to be this much is given. Calculate the rate constant and the half-life of the reaction. Yes, offline batches hai. You want to come and join? Okay, offline batches hai. You want to join in the offline batches? Use Anamani, you tell me the coupon code, and you can use the coupon code and Infinity Learn Meta app, and in the description box of the YouTube video and in the नीचे एक फास्ट URL लिंक दिया, ये URL लिंक में आप एनरोल करके you just already join in the goals coaching. Okay, Suresh 50 is my coupon code and you can follow the program parallelly with us. You can do the best, है ना, कर सकते हैं? हाँ, right. Shashank, it's Shashank, right? Okay, very good. So let's see how to do this. So when diazomethane is there, this is the given data and let us solve it. Initially A and 0 0 A minus X, let us, X is the amount is consumed and it is going to be X and X. The total pressure P naught is directly proportional to A. Total pressure at a time t is going to be A plus X. So PT is equal to A naught minus X plus X and plus X. So that ये दोनों काट कर दो, you are going to get A plus X. That's what I want to say. PT is equal to A plus X, that is total pressure. For the first order reaction, you are going to get ln P naught minus upon 2 P naught minus PT is equal to KT. So on substituting that 2 P naught minus PT is directly proportional to A minus X. So ln 36.2 upon 72.4, okay, so ये दोनों का difference है, okay, and minus PT is equal to KT. On solving you are going to get K is equal to 0.013, okay, so T half is also calculated from there, yes or no? So you can see this kind of questions from very repeated book question banks and all, okay. Anyways, we'll discuss reaction mechanism and the molecularity. Reaction mechanism and molecularity. Okay. Any doubt? You just raise your hand. If you have any doubt, you can raise your hand. Now, simple or elementary reaction. Or simple elementary reactions is 2 steps, है ना? द केमिकल काइनेटिक्स का कॉन्सेप्ट देखना था यूट्यूब पे, आपको देखना तो ज्वाइन कर लिया मैंने. वेरी गुड, थैंक यू वेरी मच, थैंक यू वेरी मच. सो आपका मेरा क्लास पसंद है? शशांक, मेरे क्लासेस आपको पसंद लग रही है? वेरी गुड. नाउ Simple reactions, the reactions which takes place in a single step are called simple reactions. Complex reactions, the complex reactions are those which has more than one step involved in their mechanism are called complex reactions. Okay, so let us talk a complex reaction example. NO2 plus CO gives rise NO plus CO2. Thank you very much. And this can be discussed in two steps. So this assumed imaginary two steps are taken. In the step 1, NO2 plus NO2 gives rise NO and NO3. This is imaginary. And step 2 में your NO3 combined with the CO gives rise NO2 and CO. So that in that case you can take the overall reaction here. 2 NO2 NO3 and NO3 काटना है. So 2 NO2 plus CO gives rise okay NO and CO2. यहाँ पर ये वाला भी काटना. Yes, it is okay. So this is a complex reaction. This is a simple step 1 and this is simple step 2. है ना? Yes, it is. Thank you very much. And let's see, generally the reactions which take place in a single step have the same value of the molecularity and overall order. That's very important point. And for an elementary reaction, the order and molecularity are the same. This is the amazing point you need to know. And also you can say we can easily write the rate law from the elementary steps. Yes, from the elementary steps only you can use the rate law and also so, but the task is to write a rate law for the overall reaction in the case of complex reaction. So ऐसे करना हर simple rate determining steps को भी you can write the rate law. So ये gives rise the product. एक ही molecule इस्तेमाल कर रहे हैं unimolecular बेटा है ना, unimolecular. So that for the unimolecular reactions the rate is going to be K A to the power 1. It is going to be first order reaction and it is going to be A plus A gives rise to product bimolecular and it is going to be K A square and A plus B gives rise to product again फिर भी bimolecular K A B. So learn the things like that. So you can have an amazing experience, right beta? A plus B plus C and 3 molecules are making a collision. Molecularity is going to be 3 beta and rate is equal to K A dot B dot C. So order is going to be यहाँ पर कितना होगा, यहाँ पर कितना होगा, molecularity is going to be 3 and order is going to be फिर भी 3 होगा. लेकिन हो सकता है ऐसे हो सकता है नहीं, है ना, कैसे देखना बेटा. So in case of a complex reactions, some steps are fast and some steps may be slow. So the slower steps are called a rate determining step. So let us take A plus 2B gives rise to C. So this is a complex reaction. In this complex reaction, let us take this occurs in 2 steps. Let us assume A plus B gives rise to C plus I is a slow step, can be a reversible, and a B plus I gives rise to D is a fast. So the slow step is going to be the rate determining step. ये slow step में ये reactant का हिसाब से आप rate ला देना पड़ता है. Rate is equal to K A dot B. So it is a bimolecular reaction, second order reaction. इतना simple है. And sometimes the question will be given in a different way. Sometimes the intermediate appears in the rate equation. So at equilibrium they can have. So A plus B gives rise to C plus I in the fast equilibrium and B plus I gives rise to D. It is the slow. So you have to write the rate expression based on this. But the rate law should not have the intermediate, so that you have to write the Kc for this. So Kc for this equilibrium का हिसाब से C plus I that is going to be C dot I upon A dot B, and from this I can be written as K is equal to K dot A dot B upon C, है ना, and put that here, so rate is equal to K and D and B and I. Put that I over here, and you mentioned the rate law is going to be given like this. Got it? It's amazing. So based on this, once already in All India Institute of Medical Sciences one question has been given long ago, and you can expect a toughest question from this kind of equilibrium oriented questions, right? Any doubt? Fine. Let us see some more things over here. Are you ready? Are you ready? Okay. So let's do class example. So write the equation which represents the rate law of each of the following elementary process. A plus B gives rise to C plus D, and 2A gives rise to E plus F. So let's see the solution. The first elementary process is the first order with respect to A, with respect to B, and therefore second and the overall order. So rate is equal to K, A plus B. Now although the second elementary process involves only one reactant A, it is a bimolecular reaction, therefore the reaction is going to be second order, not in a big issue. We know this fundamental. But if some equilibrium constant is coming, कैसे आगे बढ़ना है? So we have one more example. A possible mechanism for the reaction H2 plus NO gives rise N2 plus H2O, है ना? So that NO gives rise N2O2 is a reversible reaction, fast equilibrium, and N2O2 plus H2 gives rise N2O plus H2O. N2O plus H2 gives rise N2 plus H2O. In this scenario, if the second step is the rate determining step, let us say this is the second step is the rate determining step, my dear students. So what would happen? What is the rate law for the reaction? So this is your question. So if you go into the solution, so A second reaction, NO gives rise N2O2, this is your K. Equilibrium constant K is going to be N2O2 square upon NO square, right? N2O2 is not square, N2O2 upon NO square. Now N2O2 plus H2, it is the rate determining step, okay, is going to be K2, N2O2 and H2. But we have N2O2 concentration from here, so the rate law expression is given like this. Yes, it is very simple now. From this equilibrium expression, you can do the best. You can do all the equilibrium based questions. It's very important for competitive examinations. You can definitely expect a question from the NEET either based on the first order. In the first order, you can directly ask to calculate the rate constant, and you are asked to calculate the time if the rate constant is given, or else you can get the question from the half-life and the comparison of half-life either from the graphs or from the initial concentrations or the concentration at two different levels, and based on molecularity and the order and based on the mechanisms, you can have various number of questions. This is an example. Effect of temperature of kinetics in that collision theory. It's very simple. So a chemical reaction can occur by the collision of the reactant species. So does all the collisions can lead to the formation of a product? May or may not. So the mixture of magnesium and oxygen does not react at room temperature. Yes or no? You just leave oxygen is available, and magnesium ribbon is placed here. Does it react? No. You just take a splinter of it, you just heat it. make a fire, and it is going to start the reaction as with a dazzling flame, and it can give you the burning. But if a burning splinter is introduced to the mixture, it burns vigorously. It burns vigorously, right? So similarly, a mixture of methane and oxygen does not react at room temperature, but burning a matchstick and put the mixture bonds with explosively, and it is used, methane is used as fuel for that reason. And why it happens like this? That some external agent has to be introduced in order to initiate the reaction? That is my question. Yes, it is. You need external agents, means you need a kick start. You don't feel like studying, I come and make you to sit, and I'll tell some motivation classes, so that you are going to excited and you are going to be activated and you are now ready to study. Like that, the chemical reactions that you study and required some activation, that require called activation energy. According to this collision theory, the reaction rates for a chemical reaction to take place, reactant molecules must make a collision among themselves, right? So that collision, now in actually only a fraction of collisions are responsible for the formation of products. Not all collisions forms a product. Those collisions forms a product are called effective collisions. Those do not give a product are called ineffective collisions. Okay, so the collisions among the reactant molecules are divided into two categories: effective collisions and ineffective collisions. What are effective and ineffective collisions? So let's talk about yes. Effective collisions are the collision between the molecules which have the energy equal to the above certain minimum value are called effective collisions, and ineffective collisions, the minimum energy to which the reaction must possessed by the molecule to in order to make an effective collision, that is called threshold energy. How this threshold energy can be given? So if you want to take, this is the reaction coordinate and this is your potential energy. Okay, this is your reaction coordinate. So the reactant molecules are activated and given, this is the reactant energy and this is your product energy, and this is the amount of energy that need to be provided. So this is your called energy barrier, and this energy is called threshold energy, and this energy what I am trying to give is called activation energy. This is what is called activation energy, है ना? And this is the energy gap between these two. This is the energy gap between these two is called enthalpy of reaction. Enthalpy of reaction. This is what you call it as enthalpy of reaction. So let's talk about this. So now most of the times the molecules of the reactant do not possess the threshold energy. So we need to give that energy to reach the threshold energy, and that energy is what you call it as activation energy. In order to make the effective collisions to bring about the chemical reaction, the additional energy is required. Additional energy is required. That additional energy is called activation energy. That's what is this additional energy which is absorbed by the molecule so that they achieve the threshold energy is called as activation energy, or simply you can say EA. So if a reaction has less activation energy, the reaction is going to be faster. If the reaction is have large amount of activation energy, the reaction goes very slow. है ना? Right? And we are coming to the end of the show. You get ready, everybody. Ishita, fine. Now it is represented as EA, and I just want to say the progress of the reaction can be studied in a graph with energy of the reacting system, that you can find delta H and EA from this kind of graphs, and simultaneously I have already shown that graph, and simultaneously there are two things minded. The reactant molecule should have a proper orientation and appropriate energy. These two criteria should match in order to reaction to go for an effective collision, otherwise the collision is not going to be effective. Fine. And this is the way the reactant molecules are going to be activated, and this is what you call it as activation energy, and it is going to be a product. And the difference between the reactant molecules and the product molecules, energy difference is going to be this enthalpy of reaction. Enthalpy of reaction can be positive or negative, and negative, it is endothermic process, the reaction which heat is absorbed, and exothermic process, delta H is going to be positive, that is called exothermic process. Exothermic process. So in tomorrow's class we are going to again rediscover this collision theory, and we are going to see the Arrhenius theory. In this Arrhenius theory we will talk about Arrhenius factor and everything. Now today we had a great swell of total recapture about first order scheming is done, and molecularity and order, half-life, integrations, graphs, everything we have seen, and also we started with collision theory. And collision theory thoda sa अंदर जाने का time लगेगा. So now the time I have a class at 3 o'clock, so I need to leave. So by the way, you all don't forget to leave this, and you take advantage of Infinity Learn, the courses that are offered. I just want to show you that these are the courses, and where do you get in that session, in my session, you can see in my session, you can see boost your NEET score with Infinity Learn, enroll now, the link is available. You can click that link and you are going to direct to another page where you can enroll now. You can just see all the privileges and all the course offerings. Right in that you can see enroll now. From the enroll now you can click any of the course that you like it, my dear students, and you can click buy now, and you can enter your mobile name, and in that once you enter you will be directed to the course page. In that course page you please enter my coupon code. What is the coupon code? You tell me, Ishita, what is my coupon code there? Suresh 50 is available. From there you can do the best, and you can really enjoy the privileges and the awesome content that you have from your Infinity Learn study apps. Understand? Take care. God bless you all. Signing off. Thank you very much. Bye bye. God bless you.